let's compress a spring, and here's an object of mass m, compressing a spring by an amount, say, x naught. Right, so the uncompressed spring would be here, and it's been compressed by an amount x naught, and it's at a distance d from an inclined plane, and the angle here is beta, and there's friction on all of these surfaces with coefficient of friction mu, and we want to know how far up the incline it goes. So we can use energy conservation. From that perspective, we look at the initial energy, and we see that it's all in the spring. So we have a 1/2 k. Let's say the spring constant is k naught. So we have a 1/2 k naught times x naught squared. That's all the energy. And we have to account for that energy at the end. And we have to add in the mechanical energy that's lost due to friction, but we can account for that. So we can put it in on the right-hand side. So there's some height, right? So there's some height there, and the distance it goes up is some unknown x, which we want. So this height is x sine of beta. So we have a mg x sine beta, gravitational potential energy, plus the energy lost due to friction, which along here is mu times the normal force, which is mg, times the distance d, plus same for this, mu, same coefficient of friction. Now we have the normal force, which is mg cosine of beta, times the distance traveled there, which is x. And so now we're solving for x. So we can do this in a two-step process, 1/2 k naught x naught squared, minus mu mgd. That's going to equal to these two terms, which have the x in it. So we'll do mg sine beta plus mu mg cosine beta. Pull out the x and solve for x. So x is equal to k naught x naught squared over 2 minus mu mgd over mg sine beta plus mu cosine beta. Oops. So that's from the perspective of energy conservation. And if we wanted to do work equals delta K, then we would have 0 on the delta K side. So work equals delta K. We would have 0 on this side because the final kinetic is 0 and the initial is 0. And all the work terms over here, well, here they are. This one's positive, so we have a 1/2 k naught x naught squared. Then we have the negative work done by gravity and the negative work done by friction, cosine beta times x, cosine term there. So we have the same things, but we have minus signs, and then we can solve for x. We'll, of course, end up at the same place.